Let's try another arrangement with the pulleys. I haven't drawn the scales in, I'm just replacing them with a tension value. So this time we've got the ceiling, and the scale here is measuring the tension in this string. There's a pulley hanging from that string, and then across that pulley, over here it's connected to a wall. So from here, connected to the wall, it goes across here, down, and then we're hanging 1.5 kilograms here as well. So what is the tension in this string, this string? This is actually the same string, so it should be the same. And then T1. Well, tension here, if we look at this as our system. With this system, if we draw a free body diagram, gravity's pulling down, mg, T2 is pulling up, and since the sum of the forces here has to be equal to 0 because it's in equilibrium, that means that T2 has to be equal to mg, 1.5 times 10, so that's about 15 newtons. So again, T2 about 15 newtons. So we should see 15 newtons here, 15 newtons here, and something there. What would that be? So let's find out. Alright, so here's the system. That's the one connected to the ceiling, and you can see it's starting at about 4. So it starts at about 4 newtons up here. We need to remember that. This is the one that we'll hang the mass from, and this one is starting at 0. So this one starts at 0, that one starts at 4, and then there's one over here that's also starting, I don't know, somewhere around 4 or 5. I guess that's about 5. So this string is more or less horizontal. It'll pull horizontal when I put the mass on here. So 5 is there, 5 is there. This one says 0. Now we're going to see how much they go up when I add 1.5 kilograms. So here we go. We're expecting 15 here. And it goes up to 14.5. Not too bad. So 14.5 here. We were also expecting 15 here. So 15, and it originally started at 5. So this should be at about 20. So this is at 16, 17, 18. It's at 19. So again, not bad. So we've got what we expected here. So there's 14 there. There's 14 here. So then last time, that one went up by 30. Which means if it started at 5, it would now be at 35. But you can see it's actually at about 25. So this one went up by about 20, while these two went up by about 14. So let's see if we can figure out why. Last time we figured out what the tension T1 was when it was all hanging vertically. We did that by considering this pulley as a system. We're going to do that again. So this green loop right here, that's going to be the system we talk about now. So a free body diagram there. Pulling down this way is this T2. It always pulls, so it's pulling down. T2 is there. T2 is here. T2 is there. And then T1 is pulling that way. So how big is T1? We know that because it's in equilibrium, we know that the sum of the forces has to be equal to 0 because there's no acceleration, right? And it looks to me like that would be really easy to add using graphical drawing instead of calculating. So let's try that. So the sum of the forces, so that's a T2 down, a T2 to the left, and a T1 up to the right. So graphically, if I start in some spot and I go down by T2, over this way by T2, tip to tail, and then T1 that way, it says it should total 0, so that should come back to the same point. This one's vertical and that one's horizontal, which makes this a right triangle. That means this should be easy. T2 squared plus T2 squared equals T1 squared. That's Pythagorean theorem. A squared plus B squared equals C squared. If T1 and T2 are both 15, what does T1 have to be? So T1 equals the square root of 15 squared plus 15 squared. And that is 21. So this says that T1 should be 21 newtons. And remember, what we actually measured was 14, 14, and 20.